לא, אבל הם עשו קטע אחד. כשהמצוות תקוע, שהמצוות תקוע.
עכשיו,
אבל עכשיו נשים לב, מראים לך יותר, זה רוצים להציג אותו.
כדאי ביקש לעשות שם update, כדאי ביקש שכאן עושים Which stars, Lithuania? Okay, yeah, let's run up here.
Okay, guys.
Guys!
I'm going to start. First of all, thank you for everyone who showed up at the studio gallery today. We are going to do this a regular thing. So every Thursday we start at 9, not in the gallery, in the Vitan 26. But if we are here, then we come to the gallery. I think it's really fruitful because otherwise it's really hard to start working on tasks because you have all of it's just a regular project which you're working on. Okay, so let's go over the open task. Most of this, a lot of things are related to weak styles, I guess, and we are also going to assign some stuff that are still in to do. We're going to choose the most small things. We want to finish all the small things and then go on to the bigger components. So let's start along. Set up weak styles framework.
Yeah, it's almost there.
What exactly do you need to do?
Let's say it's there. It's done. It's like the framework that everyone is using, so you can say it's done.
Okay. But you still have some work for publishing it to GitHub pages and stuff like that. So
yes, so this was still done.
Okay. Okay, Felix, no sharding. We have IIT already described. This is actually done, right? So you can move it to results. We sent the mail about it, and really nice. We finished this task pretty quickly. Is everyone aware of this? Okay. So nothing to code. I'm trying to get to it. It's a lot of stuff that we need to document. Okay, you 6 modules.
Not much of a progress, but we might get some progress this week. So talk with the team and try to do something together.
I also know that Gabi already made working answers. So we really need to push this forward. I think this is everyone keeps asking about when will we stop putting all of the classes in global variables and stuff like that. We need to resolve it. Okay, so Donatas is working on Jasmine 2.2. I didn't hear from him. I tried to talk with him today. That's just a flow for
I'm starting it, still studying what I have to use.
Yeah, so this is actually even becoming more important.
It's also something that I've done with answers. So like,
You also did it? Okay. So probably if you would only work with our stack, then everyone in this room will have it. So,
We already had
so you can see the guys that were paying. Okay, so this is becoming even more important because we are starting a proof of concept of using Node for the server. So actually, Kfir and me and the Philips are going to work on it. And I think it's really important that from the start, we will write TypeScript. So we need all of this in our stack and to see how it's going to work.
Can you say more about this POC?
It just started, so we are just we just worked on it this week. Managed to deploy a node server which does a lot to production. This is so all of the testing will work. Yes, they are creating a local image and they are doing it. And soon, when it's going to work, we are going to start thinking about the Woods framework of the node. Okay, so how do you validate the Woods session, and how do you do all of the stuff? Do you work with battery, work with BI, all of the stuff in the node server, and it's going to be a really big project, and everyone is going to participate in it at some point. But currently, it's the first week.
What's the motivation behind this?
Motivation is that JavaScript is better.
So we're gonna have like
the real motivation is that actually we think that we are wasting a lot of time on integration between different people. When actually it would be much easier if everyone will be able to be full stackers to be able to write the client and the server-side code. And using the same language in the client and the server is the easiest way to do it.
no one will talk with Scala service, with microservices.
Yes, it's not that we are dumping Scala, we are going to use a lot of Scala services, but when you write a client, you want to write a server to it in Node.
You're not supposed to do the logic in the node, right?
We'll say it's an open question. If you have some service with some database and you are the only user of it, I know maybe you use Scala service, maybe you use the common database. We will see. We will start from small and we will see where it gets. So TypeScript into Node, it's really important. Okay, SAS source maps. No. Okay.
You decided that it's not relevant?
I don't remember. We talked about it and I don't remember what we managed. So we didn't really find a good reason to do it.
So maybe we can remove it and she can take something from the Wixlab.
Yeah.
Done.
Okay, good.
This is the reason why I didn't want to do it. Okay, next. TypeScript source maps. There is not. So this is actually something we did look at and so that it's possible and it is important. With current file, I'm going to talk with Nikas and Thomas about it. We need to find some solution because GAP is actually, we know it is better. We really need to find a good way to integrate it without making it a big fuss. So, because if you can't, we will not do it. Okay, double common extension.
I did some good progress yesterday. I solved the test points we talked about, so I guess like a week or two.
Cool. After you solved the test points. Okay, awesome. Okay, Arya, end-to-end test coverage.
Last week. I'm going to do it today.
Using the velocity, we should just move it back. Can you move it back to CSRF is actually done. So it's currently open on dashboard in production. And now we need to see how we are going to roll it to more servers. Your API?
Actually, it's done. It's already something that we use. We have a meeting to show what we did and maybe show it again. So it's actually done.
CSS experiment mixing, Zigal?
We managed the movie style.
It's going to be part of the stack.
It's a comment, just need to do that.
Okay. Kamel, is it?
It's not here, but we only sent you
Yeah, we did a full request, I will look at it today. So we're going to do some experimentation. Kamel has a few ideas about using multiple tunnels or using multiple GANT instances and stuff like that. And he tried it on his own project and he saw that it is significantly faster. It's surprising, but it is faster. So we need to validate it to see that it's really faster and not some fluke. So we're going to merge this as an experiment and then try to randomly run some of the builds with multiple tunnels and see if they really are faster, and we're going to actually have sort of BI about how fast is the build.
he messaged you in the YouTube chat, he said he made more progress, he's sending out.
Cool. Okay, so which style stats? This is the stuff that are currently open, but I think that are things in the to-do which are not in progress. So please, guys, go over your tasks and move them into in progress, because otherwise I need to go over all of this list also, which is a waste of time. Okay, so Eagle buttons. Is it reopen?
Close the thing and let's close the QA.
So I think that near you sent an email with all kinds of programs that you saw.
They have to reply in the Jira.
So
They're not supposed to reply on
we need to somehow push it so it will happen. So I think that everyone just look in the email that near you sent and see if there's something relevant for this component. And if there is, update Jira, reopen the task, and start working on it.
Just the copy paste is stuff to the Jira, which
You did it?
I do it now.
Okay. Okay, but reopen and move it to, so the people will need to move it to progress. Okay, notifications. This is Donatas. This is not here. Tooltips, Guy. Guy.
Here, yes. I think it's finished.
Okay. Okay, so
I'm not sure what the requirement exactly.
Color is also part of the tooltips.
So what the opinion?
we'll see in your email if there's something new about it.
I saw the colors on the to-do, so you can try to do that.
Okay. Without the ZL. ZL had a child. Sorry?
We just open, we put it back in the to-do, it's not
Because no one is signed it. So Wizard is a pretty big component, I think. I think we should leave it for later.
So we can put tabs also as a help. Yeah.
Tabs is something that I think that someone should take because the other is not going to do it. So does someone want to take tabs? The component for Wixstyle?
Maybe I can assign it to Maria.
Two?
Maria, remove the
Yeah.
CSS.
Cool. So, okay, so I think that the best way to avoid unnecessary work is that everyone who takes a component will first send to Alon, Igal, and also me some small document about the API that he plans to have, and we will discuss this, and after we finalize the API, then we can start working on the task. So don't start before, because you might just need to throw away your code. Okay, so I won't go over all of those tasks, just let's move them into in progress. Everyone sees his face. Move it to in progress, so we can talk about it next week.
Like that.
So did you make any progress on it? I can't move task in progress because the only one who can do it is the owner. So you should do it. So did you have any progress with the English fallback?
Fine.
Starting.
There.
Still starting. Okay, so let's go over some small components. Let's find two more. Two more small components without owners. So colors, you said that it's done, right? And the input fields, you're always on it?
Yeah, I'm on it. I will finish it today.
Okay, checkbook says it's a local for Dima. Toggles, I know the status there, drop downs. You done it?
It's in progress.
You're going to continue with more features?
For now, I will work with the contractor issue, some stuff, and then I will come back to program. So it's a
Okay.
more.
Okay, left side navigation, this is all done. Okay, search fields. I don't think, you know what this is?
And no, it's only on me because I have to calculate everything.
Yeah, so what is actually the task that needs to be done?
I know, no one took it, so
No, but it's making the search icon and the inputs.
it's not so, yes.
Okay,
I'm
so
not sure if it has more stuff in it, I'm not sure.
so I think it's pretty small. Someone want to take the search field? It's going to be a thing called the CSS task. Yeah. So let's take one more.
Do we have a component that includes search and the drop down?
You mean autocomplete?
Yes,
I don't think so.
because I need it. So I might as well write it.
So you should talk with Nereus and see if it's part of the Wix tag. And if it is, you can write it in Wix tag.
Okay.
So something else which is small sliders. Sliders. Does anyone want that sliders? Okay. Cool. So who's going to go first? Right?
Okay.
You need a computer. This
Yes,
one?
computer. Casimiro. אתה רוצה לקרוא? טוב, נעשה את זה באנגלית.
אולי נדבר על MVC.
Igen. Van,
מישהו יודע את הסיסמה של הבית ספר?
זה היה כתוב שם למטה. Slides.
אנחנו נעשה אחרי זה ראית את הפרוגרס?
אין כיסא, פול חאוס, מה אתה רוצה?
מה? סיימנו? סיים?
לא, הוא עכשיו
So hi everyone. I just start by saying that if it's not hard enough to talk about strangers, there's a live stream of me like in the screen here, so that's horrible. I'm Guy, I'm from the Ecom team. I've been at Wix for about 2 years now. When I started working here, we were working on the old system, which had no testing coverage at all, especially on the client side. Yeah, sense for a second.
Am I bothering you?
It made pushing code to production really hard. QA cycles were long. We were afraid to push code sometimes, and it made everything very hard. So when we started working on the new project, the main decision was working TDD style. And this made a lot of things easier. As we were working with Angular on the client, we of course chose Protractor. In this lecture, we will go about a library we wrote called Protractor Helpers. Now, Protractor Helpers is a library that extends the Protractor API. It adds commonly used API. It makes tests much more readable, more descriptive, and more understandable. They're basically written in plain English. And it defines the basic separation between your test logic and your app under test logic. And that's it. It contains 3 big extensions called locators, matchers, and helpers. And during this lecture, we will go over all of them. So yeah, the rest is, when we started working on the new project, things were okay. My accountant Shachar helped us a lot with starting working with Protractor. We managed to passed the first learning curve pretty okay. The syntax was fine. We had a bit of a hard time debugging, and we spent around 90% of the time writing tests, and like 10% of the time writing code, but it was okay. And then we started working on the design, and everything broke all the time. And the build was read like 50% of the day, and at the ecom we have 15 developers, and if the build is read, we don't push code unless it's a fix. So people were sitting all day long doing nothing, and everyone were being really frustrated. So we decided that we have to fix it, and the first thing that came in mind was that we have no separation of concerns. Our tests are based on our design. We use the element finder of Protractor on CSS class names, and once we change this, tests are being break. Like you move classes from one HTML to another, you change a class name, test break, and this shouldn't happen. So the first thing we did was create a new data hook, a new attribute, sorry, for HTML that was called data hook, and that was done in order to create a good separation between the tests and the design and the HTML. We created the data hook, we added to all of our HTML wherever we needed to use it, things like product widget price, retail, or add to cart button, and we stopped using the Protractor by CSS finders in most of our code. In order to use those data hooks in Protractor, we added two new locators. The first one was data hook, and the second one was data hook call. And basically what they do is they accept a specific hook name, look for it in the DOM, and return it. And if it's data hook call, it returns an array of all of those elements. And this helped us a lot. The design didn't interfere with tests anymore. The build was looking okay most of the time, and things got on track. Everyone is okay with it? No?
So I have a question. You could also, well, it's not specifically for this one, but if you're using, for example, engine model or stuff like that, it's recommended to use, sometimes it's recommended to use the locator by engine model, and then it doesn't have to do with the designs.
Yes, but then if you change the model,
right, you change the model,
break the test.
We use the by bindings, and we use the by CSS, and we use the by engine, and we used a lot of the native locators that Protractor have, if it's ng repeat or if it's binding. But at the end, we found that a specific locator for test, this is, by the way, being used in our Selenium test as well, is the most effective one. No one touches that unless he changes the test, because that's the only reason it's there for tests. But okay, so we'll get back to the ecom team now. Things were getting better, tests were working, design didn't interfere, but we still had a lot of issues. A lot of time, the viewport size between the CI and our local machine made a big break. Different browsers, all of a sudden the CI runs it on Internet Explorer in Windows 8, and what the fuck, it breaks. And scrolling to elements that didn't appear on the view screen, a lot of these things broke our tests. In addition, it wasn't readable, it wasn't English. One of the major reasons we started this was we wanted to have tests that you can basically just read, with no relations to the code. And a lot of things were a bit complicated. For example, if you wanted to maximize window, you had to write browser.drive.manage.window.that. It's too long. It's not effective. So we started creating helpers that did all these things behind the scenes for us. For example, all of our tests starts with a safeget function that navigates the specific URL, then maximize the window size to sizes we defined at the beginning of the test, and it resets to the data hook we call start point, which is the upmost part of our HTML. And these things helped us. It made things really, really simple to read. It made things work on all the browser. For example, working with select with dropdowns. We added simple example for Firefox and a simple implementation for all the other browsers, and all of a sudden we just had to write select option and insert an HTML element, and selects worked, and it made things much more easier and more readable. And then we got to the last part, the matchers. As I said, we want the tests to work in English. And
I have a question for the previous slide.
Yeah.
A specific action for if it's Firefox.
Yeah.
Why use browser detection and not feature detection? Is it more?
Don't have any feature detection here. How can you? It's not that Firefox doesn't work for a specific feature. It's just in order to work around some issue with the adapter, the driver of the Selenium to Firefox.
It's basically
special implementation.
so yeah, just what Ila said.
That's what she said.
Is it the same thing? The Firefox part isn't just clicking, so why use the others? Because it didn't work.
The option, the just click
Didn't work. No, I'm saying the opposite. If the first line, the Firefox line, what it does is clicking, but in a proposed way, then why do you need the else?
yeah, because actually browser actions, mouse moves sometimes didn't work good on other browsers. Yeah, and what we found out to be the best is gives Firefox its specific implementation, and the other browsers. So the last part in the library is matchers, and this was the thing that made it so English-like code. And it looks so very good on the screen, I think. So let's see if we can zoom out a bit. And sorry, I'm just trying.
It's not going to do anything. It's
Oh, it only changes my viewport. It's not here. Okay, so basically, this is a bunch of matchers. You can't see the names, but this is, for example, to be disabled, and the up one is to be displayed. Then what's important here is that you can see two things. First of all, instead of looking for the actual get text or looking for the attribute of disable, we have a simple English function name to be disabled or to have text, and we use that and hide the text logic behind that function. This helps us create simple English actions that describe what we're looking to do, and in addition, we have in every one of these matchers an helper function called create message. And what this does, it simply creates a message of the current context of the text, and if the test will fail, it will give you the specific message with the context and let you know exactly what failed on the test. And another thing that we had a hard time doing in Potato is understand what is failing in tests. And once we added this message to all of our matchers, it made things much more simple and much more easy to understand. So this is the matcher, the message function. You can see it accepts a context and a message, and in the end it returns a very simple and easy to read message. For example, the second test we have here, very readable again, is expect $99 to match a money pattern of our specific regex with $15 simple. This is why it failed, or like the top test fails that because the data hook we were looking for isn't displayed. And this made testing Protractor and debugging it much more simple. Now this is the library. This is everything we did. And in order to show how effective we believe it is, I took a random test, a random E2E from one of the NG groups. I took it from your GitHub, and I just wanted to rewrite it in Protractor and show you the difference. So this is the original test. And you can see that in a lot of places we use things like get attribute disabled or get attribute href. And we do things like get text to be equal and browser actions, a lot of browser actions here. And this is not, it's not a bad test, but it's not that readable. You can just have a look at it for 10, 15 seconds and understand what's going on in here. And what our library does is simplify things.
You push it later?
And we have to ask Shachar to add this to the Wix grant file, but this is the last slide. So, and like you can see things like helpers move to an element which accepts an element, and you can assume that it just goes to that element. And you can see that the tooltip should have a text, and it's very simple and it's very neat and clean. And we believe it's the right way to go with E2Es. So yeah, this is it. The last thing we want to do is open source this. We believe we've been using it for almost a year now, and we believe it's time to let the public have it because we think it's a good library. But the first thing is that we want you guys to use it, and we'll ask Shachar to add it to the grant file and have the NGKit use it.
What do you need to add to the grant file?
You have to add.
Don't we just need to require it and use it?
Yeah, but we have to require it in the protractor conf, and we can't do it online.
Why not require it in the tests?
We do it in the free, something of free.
We do it in the e-commerce tasks.
Yeah, we do it in the e-commerce task.
Why can't you just
Because you want to know
add
what
it
product.
to the project and use it?
We can take it offline.
Yeah, we can. But basically, we want to hear what you think. Maybe give us some pull requests, so new matchers, new helpers, things we did wrong, things you believe we can fix. And if everything goes okay, we can later on make it our first Wix open source project, or the first Guild open source project, which will be awesome. So, yeah, questions?
Can we use that? Can we use this library, but not, to define data hooks, or all the metrics and locators and all this stuff based on that I'm using data hooks in my HTML?
You don't have to use data hooks. You can just use the helpers of the matchers. We think that the data hooks is the right way, but you don't have to do that at all. By the way, we also use this now on our unit test. A lot of these matchers also go to our unit tests and not only to our E2Es. So it slowly becomes like a cross-platform thing, and everything that is Jasmine-based.
Not sure that everybody knows.
Oh, yeah. Unit test
is like unit test. You
Ah.
take the view and you compile it like a directive, and you can test it in unit test instead of using Productor. But
Aloni gave a lecture about it.
Yeah, we can
a while ago.
redo it.
Any more questions?
So maybe you can send, the letter to the guild, this is the project, this is the link to the GitHub, how we can start using it.
Yeah, okay.
I'd love to use it for this.
Thank you.
Awesome. It's your stage now.
It's funny because lots of stuff that I have in this talk is stuff that I learned during my tenure at the Econ Group. Had lots of trouble with we had lots of trouble with building this project because it was very large scale. And, it's funny that I'm here to give you the talk on the same day that the guy is talking about.
It's another aspect that I probably found yesterday.
So this talk, I'm gonna give this talk later, later this year, like in September, in Voxel Days, Vilnius. So please, any feedback is welcome. It's weird giving a talk sitting down, actually.
You can stand it.
Yeah, but
The computer,
yeah, it's that the stream.
Yeah, it's the stream.
Will that work?
It will work.
I don't know. Yeah. So I don't have a clicker on me. So You have a clicker.
I have a clicker. I have
That
everything.
would be awesome. Fancy.
Yeah.
Okay, so this is not a talk about code per se. It's rather a philosophical talk. It deals with design more than with code, and notes. Yeah. So, about me. So, for those of you who don't know me, I'm Shai Alin, as it says here. I've been at Wix for almost 25 years now. I started at the backend guild doing the HTML editor backend. I rewrote lots of chunks of the Wix backend code, like the public server and the meta site. I wrote the meta site, rewrote the public server. My strict thread is that I've been coding since 1994. I had a small gap during my army service, but then later during my army service, I became like I went to the Kilia, to the headquarters, and then I did some code there. I'm involved with the Israeli Scala and TDD communities. I actually helped set up both Scala conferences we had in 2013 and 2014. Right now, I'm doing JavaScript at the Core 3 team. I work with Nadav's team. I'm doing isomorphic JavaScript, so lots of the stuff that I deal with now are the same problems more or less that we had in e-commerce when I was like on the other side. But why should you listen to me? What's in it for you? So first of all, I want to say that nothing here is new. There's nothing new under the sun, really. That's everything is about. I learned lessons over the last 10 years or so of professional experience, and I read some books, and I like implemented the stuff that I learned from the books. And I'm telling you what I read in those books. And this is thoughts and beliefs that I acquired. You don't have to take them. But that's a style of coding that has helped me become a better engineer and a less frustrated engineer. Helped me calm down, to be more precise as a coder. So let's dive. What is design? When we talk about software design, what are we talking about? Are we talking about something like this? Are we talking about something like this? Well, I claim that no, the former is a class diagram, the latter is sequence diagram, and these are views of code. So let's go to the supreme authority. Let's ask Wikipedia, what is software design? So Wikipedia says that software design is the process of implementing software solutions to one or more set of problems. One of the most important parts of software design is blah, blah, blah. This is not design. That's hardly helpful, actually, because it doesn't talk about what is design. It talks about the process of design. So let's go and ask Matt Price and Steve Freeman. So for those of you who haven't heard or read Growing Object-Oriented Software Guided by Tests, I highly recommend it. That's the first book I'm gonna pitch here. It's awesome. It's considered by at the backend guild as the Bible. Every new engineer that comes into Wix receives a copy of Goose. And this, we've bought, I think, over 100 copies by now. And it's a very important book. And in Goose, Matt Price and Steve Freeman, they liken software engineering to growing biological entity, growing a plant. And I really like this analogy because to me, software isn't something you build. It's not like building a bridge. It's not like building a structure. It's not even like electrical engineering. Because our job is more like that of a gardener. We take we take software, and you all know that, the software will grow. Regardless of what you do, it will grow, and it will become more complicated over time. And our job is to nurture it, is to prune it, is to water it. Otherwise, it will rot. And think about it like that. Like, as a species, mankind has taken plants and cultivated them from simple wild stuff to cabbages and potatoes and tomatoes and whatnot. And to me, software engineering is very similar to cultivating plants because it's more about how we what's the word? How we intervene in the process rather than actually initiate the process. And when we think about design, usually we think about big design up front, like writing documents and talking to architects and class diagrams and whatever. But how does this sit with gardening? Where does design come into the picture? Where does my intent to design come into the picture when I'm gardening? So let's ask Michael Feathers. Michael Feathers wrote a book called Working Effectively with Legacy Software. It's basically a book about working with code that is not tested. Also very highly recommended, especially if you deal with legacy software. I think that none of us here doesn't deal with legacy software on a daily basis, including myself. And I work on a greenfield project. So Michael Feathers said that when you are programming, you are doing detailed design. Like when you build a bridge, for instance, then you have the engineer, and the engineer draws diagrams, draws blueprints, and does some calculations. Then you have a construction team, a manufacturing team that goes to actually build the bridge. Now, Michael Feathers says that as an industry, we used to assume that we are the construction team, the manufacturing team, and some architect who does the design is the engineer. But he says that that's not true. Actually, the manufacturing team, the construction team is the compiler of the interpreter, and the code is the blueprints, and we are the designers, we are the engineers. The Qt boxes are not designed, they are a view on top of the design, a high-level view of the design. And also, he goes on saying that as an engineering culture, as a profession, we made a mistake of distinguishing between, of drawing an artificial line between programming and design. This causes lots of waste because we thought that we are different. We thought that we are not the same as other engineering professions, but we are. We just misunderstood the way that we are similar to them. Coding and testing are part of the design. They are the design. They're not something that you do to implement. They are the act of the art of designing. And all of this, drawings on whiteboard, they're also part of the design. But it's not that this is design, this is implementation, right? So, if we take into account what the last few slides said, this esteemed gentleman that I highly revere what he said, then we must come to a conclusion about coding and design and the relationship between them. And it is that to code is to design. And as we grow our software, the design emerges. And as I said, the software will grow with or without your involvement. And the design will emerge when the software grows, and it's up to you to intervene, to fertilize, so that the design that emerges is good and not like shitty design. However, and that's a big however, we code according to some product requirements. We have lots of product people, and they tell us to do that and do that. And these requirements often change, and they sometimes change drastically. So often, if we code and the design emerges and the requirements change, we can end up with big balls of mud. So what's a big ball of mud? It's a system that has evolved over the years to a state where it has accumulated lots of waste, shit, and you can't manage it. You can read. There's a very nice article. Like here, you can see it, but I can send you the presentation later. But Google Big Ball of Buzz, you can find it also. It's a very long one. It's like an essay, but it's whimsical, I would say, like a bit comic, and I really recommend it. And they talk about big balls of mud. Are they good? Are they bad? What causes them? I read lots of these articles during research for this stuff. So if you put it differently, the requirements will change. Okay, that's a given. That's an axiom. And we know that early design decisions have bigger impacts than later design decisions. The same as when an embryo develops in the womb, a mutation is much more hurtful than a mutation in a 30-year-old, right? Because if something mutates in the heart of an embryo, it will probably not survive. Similarly, design decisions that we take early on are much more critical to the design, to the resulting software. So we must come to the conclusion that it's better off delaying or deferring these decisions to a later stage. So that means we need to focus on coding to interfaces or designing to interfaces rather than to implementations. Okay? So far? So that means that we need to take a new approach to design, and this approach is outside-in development. So when we write a class, we code to an interface. Okay, well, maybe JavaScript developers don't do that. Java developers, when they write a class, they usually code to interface.
TypeScript developers.
Okay, so TypeScript developers also have interfaces. That's very nice. We have progress right now. So we code to an interface, not to implementation. The same approach can and should be used when designing systems. When you talk to another system, when you talk to a different part of your system, you talk to an interface. Don't talk to implementation. It's like layers of onion. Each layer is an interface to the outside, and it hides the nested layer, the inner layers, which are the implementation details. And you can read a lot about outside in. I'm not going to dive into it, but it boils down to writing code from the call site. I need to write some new class. I don't write the class. I write the code that uses the class, and then I have a ready compiler, and then I create a class. I write from the outside in. Okay, and this will actually ensure that I code to interfaces other than implementation at all layers. And we carve our way into the system layer by layer from the outside in. And while we're doing that, the technological stack emerges from this carving. It's like statue making. Like English word for statue. Sculpture, yeah. Like a sculptor who works with a chisel and carves into the big chunk of marble, and eventually, a statue of David emerges. It's very similar, and you have the design that emerges, and you have the stack that emerges. The stack might be, Angular, TypeScript, Protractor, but it might as well just be two classes. It's all about the perspective. A stack is a stack, and a subsystem is a subsystem. It doesn't matter where we're looking from. And so, what outside-in development leads us to do is it helps us be more Yagan. When we're starting from the outside, so inner layers that we are working against are like a black box that we're covering. We don't know what's there because maybe it hasn't been written yet, or maybe we just don't want to know what's there because we want to go to interfaces. And we need to pay attention that when we do that, we end up with cohesive and loosely coupled systems that comply with the solid principles. Do you know what the solid principles are? Have you heard of this acronym before? If not, please Google it. Like 5 letters that talk about stuff like facilitation principles and stuff like that. And basically, that 5 rules of software engineering that you need to abide. And it promotes the Yagni principle. Yagni means you ain't gonna live it. And what does that mean? Like, let's talk about a piece of software that I'm writing. I'm writing a new feature in Angular. So I will write a view, and I will maybe write a controller, and I will maybe write some service and some HTTP service to go to the backend. And wait, do I need any of this? Is that really necessary to implement the feature? Maybe not. Maybe I don't need all of this now. And when I'm going to implement the service, I would probably end up writing additional methods, like, I'm writing a method to create and to fetch, like a book. So why not add the delete book method? I'm going to need it later, right? Wrong. You're not going to need it later. And if you're going to need it later, that's not going to be the same int. It's going to be a different int. So it's like at Wix we have a term doesn't translate well to English. It's called the preparation for an air conditioner. Gig uses it a lot, and basically, for those of you who don't know what it is, it's like in the 90s when we used to build buildings, there were window air conditioners that were very popular, and so we had to break a window to put the air conditioner in it. So architects started planning buildings with holes in the wall, where you would put window air conditioners later. But a few years after that practice has emerged, window air conditioners went out of fashion, and we moved to central. So now we have houses built with holes in the wall and nothing to do with the hole. So you wall up the hole, but you wall it up with thinner blocks or something, or construction or something. So you end up with a niche in the wall, and you put vases in the niche or decorations and stuff. But you start with it. It does nothing to do about this now. Yagni is the same about software. When you code, when you write something that you don't need, you increase the chances that is going to make it harder for you to change the software later. Because maybe someone is going to use it anyway in an unrelated fashion, like not how you meant them to use it. Or maybe it's just going to be clutter, like noise, and interfere with the ability to see the whole system. So, and the worst thing that you can do is to introduce immature indirections. So if we go back to my book example, I need to write the least amount of code that I can to implement that feature. And if that means that I add some logic in the controller, so be it. That is better than introducing a service just for the sake of delegation, because then I focus on the mechanics, and not on the semantics. I focus on the indirection, not on the abstraction. So, what are mechanics and semantics? So if we go back to the example of a book, then a mechanic is a book service, and a semantic might be a library or a bookstore. And when I think about these things as libraries rather than book services, I will have a tendency to end up with methods that are more meaningful, that expose their own language, their own abstraction, rather than have a book service that has, CRUD methods, create, read, update, delete, find all books by, and you end up with like this list of methods that you don't even use. So we like to focus on semantics rather than mechanics. And this is very nicely achieved using RTD development, because I don't even write the service. I write the interface first, and the interface will be in the language that the outside layer demands on it. Right? As I like to say that as software engineers, our job is to translate a higher level language to a lower level language. That's it, nothing else. And if we do not introduce a new language in a layer of code, then we're not doing our job properly. So, naming matters, as I said, in Petri, I don't know how many of you know Petri, the experiment system, but we don't have an experiment manager, we have a laboratory, and the laboratory conducts an experiment. And this actually propels the design towards better abstraction of the domain, the problem domain. naming directs and fixates your thinking. Let's say, it propels you towards a specific path. And poor naming will fixate you on poor language, on poor abstractions, on indirections, on abstractions, on mechanics, on semantics. When our code is Yardney compliant, when our code doesn't have any unnecessary shit in it, it exposes its own abstract language, then when we make the mistake of adding an ugly piece of code, something that doesn't belong here, something that is mechanic rather than semantic, it will be very bold. It will be very easy to see that there is code here that is ugly, that it does not belong here. And it will be easier for us to do that, to refactor it, and to find out the missing semantics. Because otherwise, we are going to be stuck with not the abstraction that we are looking for. We've seen, as engineers, in pattern abuse, we've seen in taking the patterns that are not familiar to us from past experiences, past projects, past jobs, past languages or platforms that we work in, and applying them to our current situation. And that often results in systems that have indirections and not abstractions, that have mechanics and semantics. And we need a way to help us move away from pattern abuse. But auto habits die hard. We all know that. We grew up reading software books like the Gang of Four books, maybe, or maybe the other ones didn't read the Gang of Four books. You learned about Angular and how to use services and Protractor and HTTP backend and whatnot. And we are engineers, we are coders, we are techies, and patterns are cool, and we want to use them. We want to use the new piece of technology. We want to use Angular 2. We want to use the newest version of TypeScript for this project. We want to use that new JavaScript library that just was released last week, because JavaScript libraries are released on a weekly basis now. But maybe we shouldn't. Maybe we should stick with what works, with the simple solution. Maybe we should let go of our egos and focus on the thing that helps us be more productive as engineers and to build better code. So we need a paradigm shift to help us shape these old habits of over-engineering, of pattern obsession. And this is where TDD comes into the picture. And I gotta admit that I've been doing TDD for 4 years, but I've really been doing TDD for 1 year, or 1.5 years or so. Because it took me some time to realize that what I've been calling TDD isn't TDD. It's writing tests. So let's deal with that elephant in the room and talk about what's not TDD. So the first thing that is not TDD, and I think that there is like universal agreement on that by now, writing tests after writing production code is not TDD. Okay? Everyone agrees? Good. On the contrary, on the other hand, writing tests, all of the tests for a module, before writing a single piece of code is also TDD. And that's the exact same, mistake, but from the other direction. Because right now I'm assuming that I need these tests for these features, but I don't have any evidence that I need them. Writing lots of end-to-end tests that are tightly coupled with the system's inner behavior. This is a big disease in the Angular community, as far as I've seen. Lots of end-to-end tests, because it's easy to do. These make the system cumbersome, hard to change, slow. These tests are very slow. So you have a build that runs for 5 minutes. That's insane. A build shouldn't run for 5 minutes. It should run for like this.
Runs for 15.
What's that?
Runs for 15.
I don't understand what you're saying.
15.
15 minutes? Oh, that's close. Anyway, so lots of end-to-end tests also are not TDD. Okay? And writing end-to-end tests for a part of the system, like writing an end-to-end test for Angular, is not an end-to-end test. It's an integration test, it's an acceptance test, a system test. It's not an end-to-end test. And you shouldn't call it end-to-end test because it confuses you. So we've dealt with that, like what's not TDD. So let's talk about a bit about the history of TDD, where it comes from. So basically, originally, there was a movement called extreme programming in the 90s. Extreme programming was a movement that went against the practices of, big enterprise, big design fonts, committees, architects, waterfall, yeah. So XP was very lean, very agile. The Agile Manifesto, if you've read it, is one of the results of the XP movement. And one other result of the XP movement is TDD. Now today, many people who do TDD don't really know what XP is. XP as its own methodology is pretty dead now, but it had a very big impact on the tech community. Kent Beck is credited for coining the term, and he's still one of the biggest proponents of TDD. The body of research that I'm familiar with, and I'm definitely missing stuff, is Kent Beck, Ned Price and Steve Lehman who wrote Goose, Martin Fowler who wrote Factory, which is also a very highly recommended book, especially the first few chapters. I read them to make this presentation, and really, some pennies dropped on it when I read Factory, so do that. We have copies of all of these books, by the way, at Wix Academy, and probably guilds as well. And let's talk a bit about TDD at Wix. Okay. So I joined Wix August 2010. We had no tests at all. Nothing. No one. We didn't have any JavaScript. We had Flash. We had some HTML for premium, and we had lots of Java code in 3 services: editor, public, and users. Neither of them had tests. Editor didn't even have a build. They were deploying class files to production. That was terrible. So, and public server in specific was a big ball of mud. It had one class with 3,000 lines of code called view controller, and that was where everything happened. And it was, non-deterministic. You couldn't read the class file and understand. You couldn't even read the method and understand what it does. It was spaghetti code, like the worst kind of spaghetti code that you've ever seen. And we ended up doing player-driven development. Like, we would code and we would deploy and we would pray that it works. And then we would roll back because our prayers were not answered, and then we would change something and deploy again. And that caused downtime. And this downtime lost us a lot of money, because when public is down, users cannot go to templates, they cannot buy stuff, nothing. So we started by writing an infrastructure for HTTP server end-to-end tests. We wrote an acceptance suite for the public server that ran manually, and then we started converting it to one process of build. Then we began a major refactoring of this big ball of mud using these tests. Eventually, late 2011, I deleted the last line of code from the program, and the entirety of the dispatching mechanism of the public server was covered by unit tests. So the test suite for all of the dispatching logic at Wix ran in 3 seconds, as opposed to not having any testing, but all running in 5 minutes against a deployed environment. So that made our deployment of public server very agile. We could, fix something, make sure that it works, deploy to production, recreate a bug in new unit tests, deploy. Everything works. And to this day, 4 years later, public server is still one of the better pieces of code at Wix, because it is covered by unit tests and because it was rewritten, gradually rewritten. And that's what convinced us that TDD is worth looking at. So we started adopting TDD, and we hired Sagi Rosman in 2012. Sagi Rosman is our resident TDD guru, and he told us, you're not doing TDD work. And he said, we are a bunch of smart, intelligent people, so we ignored him, and we kept on doing what we thought of TDD anyway. So he said, what, fuck you, I'm going to build P3 using TDD. And he did that. And then, eventually, 2014 or something, 2015, that will not be TDD. We should be doing outside in development. And now TDD is a major part of Linux Academy, both Java, Scala, JavaScript, whatever. And that makes me personally very proud. Let's talk a bit about the TDD lifecycle. So I think that all of you know this by now. No test code refactor, go-to-one. Anyone does not know what this image means? Yeah, these are the Uncle Bob's hats. So let's talk about this phase. So test. We start developing. Let's talk about developing a new system. Okay, so we start by writing the first test. The first test is what triggers the working skeleton. The very first, very primitive, very simple feature of the system. Hello world, for instance. And this test would be failing because we don't have any code yet. And this test would be in English. Okay? Like Guy said, it needs to be readable. It needs to be to represent its own language. And we examine the test and we make sure the test makes no assumptions about implementation details whatsoever. Okay? Then we go to code. So we implement we make the test pass and we write the simplest possible code. No design, no libraries, nothing. No, we can do it. Just to make it work. And that's essential because right now we focus on making the test pass. We do not focus on design. We do not focus on code reuse. If we need to copy some code to make the test pass, we will copy the code. That's okay. That's perfectly fine at this stage. And this stage will tease out any complexity that we hadn't considered before. The first test, the working skeleton, is going to take a long time. It might take weeks to make it pass. And that's okay, because this forces you to deal with all of the integrations in your system early on. And then later, when you want to add the first real feature, it's just a feature. It's not integrations. All of the integrations are in place. So, what does that mean for you guys? Integrate with the server early. Write client code, write server code. Have an end-to-end test that exercises both of them. Well, when the server and the client do absolutely nothing, maybe the server returns hello world and the client displays it. But this will tease out all the integration parts. And that's okay. And by the end of this phase, we have ugly code that makes our end-to-end test pass. And then we refactor. Then we look at the code we just wrote, and we look, and if that's not the first test, then any code that was affected by the code that we wrote. And we detect code smells. And for instance, if we duplicated some code first, then earlier, then that's a smell. So now that's the time to maybe extract this code to a common place. And we determine solutions to this space, and these solutions are called design patterns. Design patterns are stuff that is meant to solve code smells. They are not stuff that you exercise on their own right. And an iteration by iteration, both in the micro and the macro, the design emerges. Now, to me, refactoring is the most important step of software engineering, of the TDD cycle, because this is not the magic happens. You know, it's very feasible to write software that makes a failing test pass by implementing it using very simple code. But you can probably never write software to refactor automatically. You can write software to help you with refactoring, like you know from Java maybe, but you will never be able to write software that does refactoring intelligently, because this is art. This is not science. This is looking at code and detecting smells and implementing design patterns to solve these smells. And when I say that to me refactoring is the most important part, what I mean is that to me refactoring is your job, not writing code. Refactoring, because you could be replaced as coders by machines, you could never be replaced as refactorers. And sometimes we don't do refactoring. Why don't we do refactoring? Because we forget about it, because we don't understand how important it is, because maybe we don't have time, maybe the product manager is pressuring us to deliver the next feature So refactoring isn't something optional. Refactoring isn't something that you do when you have time. It isn't something that you do gradually. Don't refactor on Thursdays. Okay, refactoring is part of your coding. So if you do the when you become very like when you get better at it, then you will find out that your coding cycles become shorter and shorter. Maybe one TDD cycle is 5 minutes, 10 minutes, an hour, and you're refactoring anyway. So once every 5 minutes, once every 10 minutes, once an hour, you refactor. And when you do that in that very small resolution, then very fine resolution, then it's very easy to detect code smells because you have very little code that has changed since the last good version, which was refactored. So you take a code which is perfect, and then you add one test and you add one feature to it to make the test pass, and then you refactor. And it's not going to be a bug because the code was perfect earlier, so now it's perfect, except for this duplication, or except for this other symmetries. That's it. But what is refactoring? It's a word that we talk about a lot. What does that mean? So refactoring is the process of changing a software system in such a way that it does not alter the external behavior of the code, yet improves its internal structure. It's a disciplined way to clean up code that minimizes the chance of introducing bugs. And when you refactor a system that is covered by tests, you have almost no chance of introducing bugs because the test will fail. In essence, when you refactor, you are improving the design of code after it has been written. And this is where emergent design happens. This is design, the refactoring phase. TDD, as I said, it urges us to code in small increments, and it holds us back from making drastic changes that are not necessary. Remember that TDD helps us become more young and compliant. So, the result of refactoring will be small. I actually covered that a few slides ago. What you need to remember, the test code is code. So everything that I said up until now applies to your tests as well. So your tests need to have their own language, their own domain model, their own abstractions. And if you have awesome production code but sucky test code, like what triggered the e-commerce guys to introduce all these matchers and helpers was that this test code was sucky. If you have sucky code, you have sucky code. Sucky test code, you have sucky code. Because if you cannot change your tests, if you cannot evolve your tests, you cannot evolve your production process. Test code is code. And again, if I can write software that makes a failing test pass, then isn't the test code much more important than the production code? Can't I actually say that our job is to write tests and to refactor more than it is to write code for the algorithm? So very important. Tests are code too. Tests are people too. So how do we start? When we want to start a new project, when we want to start a new feature, how do we start a TDD cycle? So we have a product manager. Product manager is the customer. It's she who defines what we need to do, right? So we sit with the PM and we ask her, what's the next most important feature? Or what's the next most important features as we currently understand them? That's important because whatever we're talking about, 2 weeks, 1 month, 2 months down the road, it's not going to be the same requirement. So we go over the product requirements as we understand them now. We enumerate them and we prioritize them. And we take the most important feature, or maybe the most cost-effective feature, best we do the product manager to decide. And if that's the first project, then this is where we pick that first very simple feature, we make a working skeleton, and then we follow down the rabbit hole. And many hidden issues will surface, many things that we haven't talked about will surface now. Because we just took functional requirements and converted them to something technical. And we didn't think about anything in advance. We didn't do a design process first. We just dived right in. And this is design. This is where we find out what we didn't think about. And the upside of this as opposed to doing design upfront or on paper, is that you have running code now. So it's much faster to actually test your assumptions, test your ideas, maybe validate this. So actually, if you talk about the TDD cycle, it's not test code refactor, right? Well, it is for unit tests, but for designing systems, it's this. It's a cycle within a cycle. You think about important feature. You write a test, you write a code, you refactor. You write a test, you write a code, you refactor. You write a test, you write a code, you refactor. Eventually, the feature is done. Go to one, the feature, and other thing. Okay? And when you think about it, this is meditation. This is something that is very repetitive, and if you do it slow but precise method, it can have a calming effect on you as an engineer. It helps you set your mind on processes that are almost meditative. If any of you practices yoga or meditation, you know what I'm talking about. It's the repetition that makes it easier to focus on stuff and be more open-minded. And TDD is a way of life. And it helps us cultivate the beginner's mind. You really need to cultivate the beginner's mind to be able to adopt TDD. What does that mean, to cultivate the beginner's mind? So when you're a beginner at something, you don't know anything about it. You're brand new to some technology, to some language. And that helps you because you don't have any prejudice. You're not jaded. So if I keep a beginner's mind, wherever I go, it helps me deal with feedback that I get from tests or from my teammates, and to set aside the patterns that I'm used to overcome my implicit tendency to do pattern abuse, to do over-engineering. It really helped me. I used to be an over-engineer. Maybe some of you remember me as an over-engineer. Nowadays, I really try to avoid that. And TDD is the way that I managed to do that. And also, a beginner's mind, we are engineers, we are smart, we get paid a lot of money, we have pride. And pride is dangerous, because pride clouds our judgment. And keeping a beginner's mind helps us overcome or set aside our pride and to let go of our egos. And that is how we are able to listen to the feedback from the tests and to write code that leads to better design. So let's go a bit about shopping. So cultivate a beginner's mind. Let go of your ego. You still ain't gonna need it. Okay? So don't write code that you don't need. In TDD, you are not supposed to write any code that's not there in order to make a failing test pass. That's very clear, because writing code that you don't need, it can only harm you. There's absolutely no chance that writing code that you don't need is actually going to improve your situation. At best, it's not going to harm you, but it's never going to be useful. And remember that abstraction belongs in the test just as much as it belongs in the production code, maybe more. And remember that abstraction is not writing another surface. Abstraction is writing language. It's inventing the language to deal with the common domain. So that's all. I've been shy. Thank you. Good night. Questions?
Do you like the code?
Yeah. It's very hard to get the 9 smartest engineers at Wix to do TDD, but we will, like on Sunday, we're starting to write the working skeleton for the new editor. So it's promising.
So if you're bootstrapping a new project, not particularly in Wix, say startup. Okay? So if I go and I want to make a startup and I want to build a product, should I write a TDD or I should not? Or
well, that depends. I would say yes, but a startup situation in many cases means that you have to be very, very quick in your it's not only that the requirements will change, maybe we'll pivot. So in a startup, what I would do is write a prototype. It is the simplest possible thing without any tests, without any code reuse, something that is throwaway code. And I will throw it away and I will rewrite it gradually when I succeed. If I was to start something that I knew that it was gonna be a hit, and I had another funding, I would do it with it. Yeah, definitely. But it's it's about compromise. Yeah.
Still missing. I know you went against the design patterns, but I still think there's a place for collective knowledge, and I'm trying to think where in the process do you, if you at all use some of the knowledge you have.
I'm not against design patterns. On the contrary, I really like design patterns. I'm against the abuse of design patterns. So design patterns are meant to, and if you read refactoring, that will become very clear to you. Design patterns are meant to solve specific code smells. You use Visitor for this code smell, and you use Service for this code smell, and you use Flyweight for this specific code smell. You don't just take a design pattern and you throw it at your problem. You first solve the problem without a design pattern, and then when you have code smells, then you design patterns. Definitely there's room for design patterns. Don't get me wrong. But it's the pattern abuse that bothers me. It's our tendency as engineers, as proud, as techie people, to use technology just for the sake of technology. Thank you. Any feedback that you might have for me about the way I